Hey guys, this is Aaron from RF Digital. Today I'm going to be showing you how to set up omnidirectional communication from one Simblee to another. I have with me the Simblee Development Kit, number RFD 77803, my iPod, and my laptop. Let's get started. Today we'll be using the 29 GPIO, 7 GPIO, 2 LED button shields, USB programming shield, and a AAA battery shield. In the Arduino IDE, open the Send sketch under File, Examples, SimbleeCOM, Send. Let's walk through this sketch. First we have the include SimbleeCOM.h line. This includes the SimbleeCOM header file with definitions of functions. Next we define our payload. With each send function, we can send up to 15 bytes in SimbleeCOM. This is what we will send to the receiving end. Let's move to the setup function. Here you'll see the SimbleeCOM.begin function call. This starts SimbleeCOM and gives us communication functionality. Next we have our void loop function. Within this function you'll see one function call, SimbleeCOM.send. This will actually send the payload to any receiver listening. This function takes two arguments. The first is our actual payload. The second is the size of the payload we're sending, so that the receiving end knows what to expect. Let's upload this sketch to our Simblee. Take your USB shield, 7-pin GPIO, and fit them together, making sure the headers line up correctly. Add an RGB LED shield on top of that, and plug it into any standard USB port. Go to Tools and make sure the correct COM port is selected. Compile and upload your sketch, and this Simblee will begin transmitting. As you can see here, there's no visual indicator that it's transmitting. Let's change that and turn on the LED when it sends. Under your payload definition, let's define your LED variable. Int LED equals 3. That should give us a green light. In your setup function, above SimbleeCOM.begin, add pin mode, LED, and set it as an output. Remember that the pin mode function takes two arguments. The first is the pin, and the second is the mode that you want to set. Scroll down to the void loop function. This is where we're going to turn our LED on and off. Under the SimbleeCOM.send function, let's turn on our LED. Add digital write LED high. Next, let's add a delay of 50 milliseconds. Type delay and put 50 in the parentheses. Next, we want to turn off our LED. Again, do a digital write LED low. Let's delay for another 50 milliseconds, for a total of 100 milliseconds. Compile and upload your sketch, and you should see the changes immediately on your Simblee. You'll notice that the LED flashes on and off every 50 milliseconds on each send. Remove your Simblee from the USB shield and plug it into the AAA battery shield. Flick the switch on the side, and you're externally powered. Let's add a receiving device. For this, you'll need a USB extension cable. Remove the USB shield from your laptop and plug it into your extension cable. Then plug that into the side of your laptop. Take your 29-pin GPIO and plug the USB shield on top, making sure the headers line up correctly. Then add the LED button shield. Back in the Arduino IDE, open File, Examples, SimbleeCOM, and click the Receive sketch. This sketch is just a little bit different than the last. You'll notice in the setup function we have a serial.begin command. This will allow us to see the data that we receive on the serial console. You'll also notice that the void loop function doesn't have anything in it. Everything that we need is going to happen in the SimbleeCOM_onReceive function. The commands in this function will print the RSSI, ESN, and payload to the serial console. The first line prints the RSSI, which is the received signal strength indicator. The second line prints the ESN, which is the electronic serial number of your Simblee device. Each Simblee has its own unique ESN. And this for loop will print each byte of the payload to the serial console. We'll end that with a new line. Let's compile and upload this sketch. Go to Tools and Serial Monitor, and you should see data on your screen. In this data, you'll see -44. That's our RSSI. If you move your sending device farther away, you should see this number change. Second, we have our ESN. After that, the console shows the bytes of our payload in hexadecimal format. So you'll see 1 through 9 and A through F. Go ahead and close that. Since there's no visual indication, let's turn on the LED when we receive a payload. Under the include line, add int LED equals 4. Pin number 4 is connected to the blue LED. In the setup function, under the serial.begin command, type pin mode, LED, and let's set it to an output. Scroll down to the SimbleeCOM_on receive. Before we print our RSSI, add a digital write high to turn on our LED. Add a slight delay of 20 milliseconds and another digital write low to turn our LED off. Compile and upload your sketch, and you should see the changes on your second device. Now look at your device. You should see the blue LED blinking. You can find more documentation at Simblee.com.